Hey, what up guys, welcome back to my programming channel, and today we're going to discuss how blockchain works, and we are going to answer a very interesting question, namely what is stopping me from telling Bitcoin blockchain that I have a million Bitcoins. So as we talked about yesterday guys, Bitcoin is a decentralized network, a decentralized protocol, meaning that there is no central entity that can verify my transaction. So what is the mechanism that stops me from tricking the whole network and telling everyone that I have 1 million Bitcoins? Let's talk about it. So before we can understand blockchain, we need to understand two things. First of all, what a hash function is and how a hash function works. And number two, we need to understand what a Merkle tree is and how Merkle trees work. So let's get into what a hash function is. And I've made a picture just for you guys. So as we can see here, a hash function is a one-way function, guys, meaning that it can take an input, and the input is usually a sequence of bits. So it could be a movie like this, or it can be a picture, it can be any digital data, guys. So the hash function will take this input and produce a fixed size value as output. So for example, if I insert this input, I'll get this output. However, guys, if I change only one bit in this input, only one bit, this whole output will be completely different. It will be completely different, guys. And so this is the property number one of hash functions. If I change only a single bit, the output will be completely different. And the second property, guys, is that this is a one-way function, as I said before. There is no way for me to figure out the input if I only have the output. So if I have the input, I can get the output. However, if I only have the output, there is no way for me to get the input. So this is how hash functions work, guys. They take an input and produce a fixed size output. I mean, the input can be many gigabytes of data, but the output will usually be a fixed size value that is a lot smaller than the input. And there will be no way for me to go back to the input. Right, so this is a hash function, guys. The next thing we need to understand is what a Merkle tree is. And a Merkle tree is a data structure where each layer is a combination of hashes from the previous layer. Let me show you how this works with another picture. Let's say I have two values here. To get the next value in the tree, I hash them. I combine them to a single hash and get this value. So guys, as I told you before, this is a one-way function. So by having those two values, I can get this value. But by only having this value, there's no way for me to figure out those two values. And I do the same thing here. And then I combine those two values into this final value, the root value. And so this root value will be a representation of this data structure, but there is no way for me to go back and figure out all the individual values in the tree. That would be very difficult. So this is a Merkle tree, guys. We combine values from the previous layer in the tree to get the next layer, to the next value. Right, so now we understand what a hash function is and what a Merkle tree is. So guys, now we can start talking about a blockchain. What is a blockchain? So I have another picture for you guys, which illustrates the blockchain. And the blockchain really is a huge Merkle tree, as you will see. So all blockchains have some kind of root value. And when I do a transaction, for example, when I send 10 Bitcoins to my friend, this will be a transaction. And this transaction will be hashed together with the previous root and create a new root. So let me show you again. So this is almost like, it's very like a Merkle tree. In fact, it is a Merkle tree where I have a root, and then I hash it with a transaction and I get a new root. Like this. So I have a root, I hash it with a transaction and get a new root. And then another transaction comes in, and it gets hashed with this root and creates a new root. And so guys, now we can really understand why I can't trick the blockchain. Because if I wanted to trick the blockchain, I would have to say that in some transaction before, I received 1 million bitcoins. However guys, the network will then take my transaction that I say happened, but in reality it never happened, and they will just verify it. They will hash my fake transaction with previous root, and they will get a different new root than compared to what everyone else has in their copy of the blockchain. So this way, it's impossible for anyone to trick the system, because everyone else will be able to verify your transaction and whether it is valid or not. So this is how Bitcoin blockchain works, guys. We have transactions that get merged into the blockchain by hash functions, and they create a new root, and then next transaction will be merged into the blockchain by hashing it with the current root, and this will create a new root, and so on. And so everyone can verify each transaction, and there is no way to fake it. Okay guys, so this is a Bitcoin blockchain. An interesting aspect, or an interesting question is, okay, how does Ethereum blockchain work? Because as we talked about yesterday, Bitcoin blockchain is just a blockchain for transferring value and verifying transactions. Whereas Ethereum blockchain actually can execute code. Ethereum is a decentralized app platform, a platform for decentralized application, meaning that you can write decentralized apps. So what is the difference between this Bitcoin blockchain and Ethereum blockchain? Well, in Bitcoin blockchain, we have transactions that get merged into the blockchain like this, and they create new roots in each step. However, in Ethereum blockchain, instead of transactions, we have states. And so as a software developer, you're most probably familiar with states, guys. And the state is just a configuration your program is at a specific time point. So when I execute my code on Ethereum blockchain, each and every state will be merged into the blockchain, and it will be publicly visible, guys. And so it will then, in the future, we could see all the previous states of all the programs that ever got executed on the blockchain. And this is really mind-blowing. And a question I have is, how can this system ever scale? Because it seems like it's an enormous amounts of states that will be created in the Ethereum blockchain. However, I'm sure they have it figured out, and I mean, it works. Ethereum works, so I'm sure they have some kind of mechanism that makes this possible. But every single state in your programs will be merged into the Ethereum blockchain, and everyone will be able to verify all the states. So that's it, guys. We talked about how a blockchain works and how Bitcoin versus Ethereum blockchain work, and why I can't trick the Bitcoin blockchain and tell that I have 1 million Bitcoins. Let's just do a quick recap. So we have a hash function, and this takes an input and gives me an output, and I can never go back. We have a Merkle tree, which can hash two values together and create a combined hash, which will be the root of these two hashes, like a root hash. So we have several branches that we can combine into a root like this. And the blockchain is basically a Merkle tree where we In a Bitcoin blockchain, we merge the transactions into the blockchain. And in Ethereum blockchain, we merge states into the blockchain. And the reason why I can't trick the Bitcoin blockchain is because if I tell the network that in these transactions I received 1 million Bitcoins, everyone will be able to check the hash and realize, no, this is false, and we will not give you your 1 million Bitcoins. That's it, guys. We talked about the blockchains. If you're a new viewer, guys, you should definitely subscribe if you like technology, development, programming, blockchains, and artificial intelligence, because I'm a software developer and I post videos every single day, guys. I see you tomorrow.